Okay, everyone, how's everyone doing? Hope you had a good weekend. Um, I'm calling this a test retake test review. I know we had some issues with the test on Friday, so I'm kind of thought about it over the weekend, and I've come up with this plan. We're going to kind of go over the plan right now quickly, and then I'm going to go over the review packet that we did on Thursday to show you how to do each one of the problems that we had on the test, and then we'll go from there. So, to go over the plan. I'm grading the test that you took on Friday. I'm going to find out what percentage of points you scored. So it was out of I forget how many total points it was. So if you had 85% of the points, you're going to get an 85%. On Wednesday during the half day, you're going to do one problem that is exactly like the problem, not exactly like it's going to be similar style, different numbers to the last problem that was on the test on Friday. So you're going to go through, you're going to fill in the chart with all the numbers. You're going to calculate your means, your standard deviations, the correlation, the slope, the y-intercept, and the regression line, and then you're going to have to answer one more question based on the regression line. That's what you do on Wednesday. It has to be completed on Wednesday. That's going to be worth 100 points. So let's say you bang on that, you get 100 points on that. You get all 100%. So now you have 100 and an 85. What I'm going to do then is average those two scores together. So if I average 185, it's 185 divided by 2. Your average then is a 92.5. So rather than getting an 85 for the test on Friday, you'll get a 92. The example I'm showing is if you earned 70 on the test from Friday, and then on the problem on Wednesday you get a 94, I'm going to average those two grades. So your final grade for the test would be an 82 rather than 70. So I'm trying to boost everybody's score. I know the test was hard. I know it was longer than I expected. It was longer than I expected. And then it just became kind of a bear watch, and you guys tried to struggle through it. I mean, everybody did an awesome job working through it. But just to kind of boost grades, I don't know what the grades are. I haven't graded them yet. As you can see in the bottom, I haven't graded any of the tests. So I don't know where you are. You have a pretty good idea where you thought you were. So the one exception I will say is if you do better on the Friday test than your average score, so like say you just bomb the thing on Wednesday, I'll give you your score from Friday. I'm not going to hurt you from what you did on Friday because Friday was the test. But what I'll do is I'll give you that score from Friday. I'm just giving you the option and the ability to boost your grade based on what you got on Friday after you've seen how to do all the problems. So I would definitely recommend following along step by step, writing down the notes of what I'm doing so you can see what you need to do. There's not going to be any questions that you're going to need to answer in Edulastic or Edpuzzle, except right at the very end. So you can pause the video, you can rewind the video if you need to kind of pick up what you missed. But I definitely want you to kind of sit through and see how to do the problems so that then you know how to do that last problem on Wednesday so you get a really good grade on that to boost what your average was for when we average them together. I hope that makes sense. I hope it's fair. I know some of you guys were a little bit concerned when you came in on Friday that you were already asking for retakes. So I just want to make sure that we all know what's happening. And again, on the thing on Wednesday, you'll have access to the equations again as well. So to move on to the review. So from Thursday's review packet, again, I've reprinted this. I've attached it to the assignment in Classroom so you can print them out if you want to look at it or just take notes on a piece of paper. We had this equation. We had the output from a TI-84 calculator. We have a standard deviation and mean box that's not shown in the TI-84 output. And we were asked to come up with the regression line and verify the slope and the y-intercept and then predict the arm span for somebody that's 64 inches tall. So the first part of the question was pretty simple. It's report the regression equation using the words height and arm span, not x and y. We see in our table y was arm span, x was height. If we look really quickly here, we have a and b over here in our box. So I know if I kind of use the numbers, I have y equals 16.802. I'm going to kind of truncate that, plus 2.249 x. That's what the regression line looks like. They wanted it as arm and height. So we're going to arm span and height. So all you're going to do is arm span. That's my y value, is the arm span, equals 16.802 plus 2.249 times height. So that's all we need to do for that. Next thing was to verify by using the slope formula. Again, they've given us the slope. We know what the slope is. We're just trying to verify it. So we have our slope formula here. SY, SX is our standard deviations. So we see what those are. Our correlation is the R value in our box from the TI-84. So B is going to equal 8.1 divided by 3.41 all times 0.948, say 0. Does that make sense to everyone? Does everybody see what that looks like, what that seems like? And if we do that math out, we get B equals 2.251. Pretty close to the 2.249. Again, it's a rounding thing. Like I said, on the test and on the stuff on Wednesday, I'm not worried about the rounding. As long as I can see what you did, I'll kind of look and see how you rounded it. I have a pretty good idea of where the numbers should be for what we're working on, so that I'll know if you're way off. I just saw on Friday, I could kind of see when your numbers didn't look quite right. But don't worry about the round. Just round it to where you're comfortable with. I recommend on Wednesday doing just 2 decimal places, because that's all I'm going to do on my side when I'm doing the answers. So that's what I would recommend. So now to verify the y-intercept they used, we're going to use our formula A equals y, the mean of y minus the slope times the mean of x. So if we set that up in equation formula, I have A equals, my mean of y is 159.86 minus my slope, I would use the 2.249. And then my mean of x is 63.59. Again, the reason I'm using their slope is I'm trying to verify their y-intercept. So if I use our slope that we just calculated, I'm not going to get the right y-intercept. So when you do that math, we end up with the y-intercept equaling 16.78. Does that make sense? So you kind of plug it in, try to see what I did, where the numbers are coming from. I've given all the formulas on this stuff, so you have it all. Now to use the regression equation to predict the arm span, we're going to use their regression equation. So we're going to use y equals 16.802 plus 2.249. I'm going to change color here because I'm going to plug in an x value for somebody that's 64 inches tall. So x is 64 rather than x. Again, you do that math out, and we end up with 160.80. So pretty close to what the y-intercept was, just moving the decimal point up one spot. Does that make sense? Apologize if my math's off, but I think that's pretty accurate, pretty right. So does that make sense to everyone? So it's not going to be on the Wednesday part. It's more the Wednesday is the last problem. I just kind of wanted to show everybody this, so that maybe they can kind of think through and, oh yeah, I actually did that problem right on Friday. Okay. Next slide. This is another one kind of caused a little bit of problem, just to kind of show you what the process was. Maybe then you'll see, oh wait, yep, I did that one right too. We're trying to create the regression line ourselves this time from the data that they've given us. So if we remember, my regression line is A plus BX. So the first thing I need to find is I need to find my slope. So the slope formula is the correlation coefficient times the standard deviation of y over the standard deviation of x. They've given us our standard deviations. In this example, they're both 10. My R is 0.7, so this is just going to equal 0.7 times 10 divided by 10, which is 1. So my slope is actually just 0.7. Make sense? Did everybody see that? They gave us an n. We don't really need it for what we're doing here. Just extra information that we didn't really need. So now we need to find our a, which if we remember, a is the mean of y minus the slope times the mean of x. I have my slope, I have my means, so I can plug in. A equals 75 minus 0.7 times 75. That all calculates out to be 22.5. Everybody see that? Good. Because this actually is 75 minus 52.5. Okay. So then they're saying to predict what the final score in the final exam would be for somebody who got a 95 on the midterm. So actually, one last step. Our regression line is y hat equals 22.5 plus 0.7x. So that's our regression line. This is what we're looking for that we're going to need to do our last question here, the last part of the question. Somebody gets a 95 on the midterm, what's their final exam grade? So we have y hat, whoops, going to equal 22.5 plus 0.7 times 95. 0.7 times 95 is 63.5. So this equals 22.5, 22.5, 63, sorry, no, 66.5 plus 66.5, which equals an 89. Does that make sense to everyone? Does everybody see how we got the equation? We had to find the slope, which is a correlation times the standard deviation of y divided by the standard deviation of x. Then you have to plug that into our equation with our means to find the a value. We get our equation, we get our regression line, plug in our x value of what we're expecting, and we get our y value. Hope that makes sense. Okay. So now to work through the big long problem at the back. Kind of eliminated some of the stuff that was on the review packet. But again, we have the chart. So each one of these column headers corresponds to one of the parts of the formula sheet. So if we look for standard deviation, the top part of the standard deviation equation, we need x minus x bar squared. That's our second column there. That's the top part of your standard deviation equation. To find your standard deviation, you're going to figure out what all these values are. Then you're going to add them all together. You're going to divide by n minus 1. So you count up your n's. 2, 3, 4, 5, 6, 7. So all our division in this is n minus 1 is going to be 6. Okay? So you add that column up once you find out what it is. You divide by 6. And then you take the square root of it. Don't forget to take the square root of it. I'll try to kind of fit these calculations in the screen somewhere here. But that's what that is. The next column is what we need to kind of figure out for our correlation. So we're just going to take our first column, our observation minus our mean, and divide by our standard deviation. So to get our correlation, we're going to take all those values for the x, multiply it by the corresponding value for the y. We have our correlation kind of coefficient for each observation. That again, you add all those up, you divide by 6, that's your correlation coefficient. Hope that makes sense. So, first thing we do is we add up all our numbers. This should be point, not comma. So when I kind of go through that, add up all those numbers. Let me grab my calculator here quickly. We'll do it live for the first column, and then we'll kind of just give you what the averages is for the watt times. So I have 1.141 plus 2.979, 3.346 plus 1.048 plus 2.343 plus 1.804 plus 0.218. So that equals, so if I add this column up, it's 13.579. Remember, the mean is the only thing we actually divide by the total number of observations. So I'm dividing that number by 7. And I find that the average for my distance, if I round to do decimal points, is 1.94. Does that make sense? Everybody see that? Okay, good. If I do the same thing for the time, I find out my average for time is 4.40 hours. Does that make sense to everyone? Okay. So now we're going to take our means. So this is going to be our observation minus 1.94. So all the way down that column. Again, I'm rounding to 2 decimal places. Is what I'm rounding to. So this becomes, remember your signs, negative 0.80, 1.04, 1.41, negative 1.92, 0.40, negative 0.14, negative 1.72. Does everybody see that? Everybody good with that? Okay, now we take the square root of all these. This is 0.64, whoops, 64 not. Again, I'm rounding to 2 decimal places, so this is 1.08. That's squared, not added. This is going to be 1.3. Okay, so I have all those values for my x. I'm just going to do the x's. I'll let you do the y's on your side if you want to kind of figure it out yourself to make sure you're doing the right math. I will post what I have for answers out on the link as well, so you can see what you got. So now I need to add this column to figure out what my standard deviation is. I'm going to write right in here in blue to see what standard deviation is. I should do it over here. So my standard deviation, so S of x, I'm going to call it, is the square root of the sum of x minus x bar all squared divided by n minus 1. Not m1, n minus 1. Sorry about that. So when I add up my columns here, I end up with 9.85. So I plug that in over there. I get 9.85. Remember, I'm dividing by 6. So I end up, what I'm looking at here for my standard deviation is the square root of 1.64. Again, take the square root of that. So I get 1.28. So my standard deviation for distance is 1.28. Does that make sense to everyone? Okay. So now I go through, I take my X bar column, so this is the X bar column, that should be bar. So this is column 1 divided by my standard deviation now. So divided by the 1.28. So this here, you got to worry about your negative signs. So I have negative 0.8 divided by 1.28. This tells me this value here is negative 0.65. Again, I'm just doing 2 decimal points. The rounding is going to get way off. Just don't worry about it. So I got negative 0.65. 1.04 divided by 1.28 is 0.81. Positive 0.81 because it was positive 1.04. Remember, we're dividing this column, not this one. Don't divide that column. 1.41 divided by 1.28 is 1.10. Negative 1.92 divided by 1.28 is negative 1.5. 0.4 divided by 1.28 is 0.31. Negative 0.14 divided by 1.28 is 0.11. And a negative 1.72 is negative 1.34. So I've calculated all those for my X. To save some time in the video, I'm just going to kind of write in what the values were for Y. This was negative 0.79. This was 0.81. This is 1.44. This was negative 0.08. This was 0.30. This was negative 0.08. And negative 1.59. Okay. So you should be really close to that as you do your rounding. Now for my correlation, to find out what correlation is, then the standard deviation for my time was 1.98. Okay. So now we're going to multiply the correlation numbers together. Again, be careful of your signs. And again, I'm rounding to 2 decimal places. Actually, I'm going to round this one at the end. So I'm going to call this 0.5135. Negative times a negative, so it's positive. 0.81 squared is 0.6561. 1.1 times 1.44 is 1.5840. This is 0.12. This is 0.093. This is 0.0088. And the last one, 0.34 times 1.59, 2.1306. So we've done that. We've multiplied each one together. Now we add all those up. So if I add that column, I get 5.106. Again, I'm dividing by 6. So my correlation is 0.851. So we'll call that 0.85. Remember, correlation should be between -1 and 1. So if you had something bigger than 1 or -1, you've miscalculated. Okay, so that's how you're filling out the table. Hope that makes sense to everyone. So now I have all the information I need to do all my other stuff. I don't think I have a blank slide. Maybe I will, if I'm lucky. Nope. Okay, so we'll do it from here. Remember, slope is correlation. Oops. Kind of fill it right in here. Slope is correlation times standard deviation of y over the standard deviation of x. That's going to equal 0.85 times 1.98 divided by 1.28. So my slope is 1.31. That's my b. To find my y-intercept, I'm going to do this up here. A equals my average of y, 4.40, minus 1.94 is my x, times my slope is 1.31. So my A is going to be 1.86. And then my equation is going to be y equals 1.86 plus 1.31 x. Then they ask us how much time it would take to fly 3,000 miles. Again, we look, and my distance is all in decimals, 1 point. So it's really, this is in thousands of miles. So if I'm going to do 3,000 miles, my x is really going to be 3. So it's 3.000 for my x, which I'm going to plug into my equation. So y equals 1.86 plus 1.31 times 3 equals 1.86 plus 3.93, which equals 5.76. So we're saying it would take 5 and almost 45 minutes to fly to Seattle. So I hope that makes sense. Those are the steps. That's what you need to be doing on the chart on Wednesday. We're going to be doing an analysis of some stock market returns, some stock market values. So it's kind of a real world example. So that's what you'll be doing. Again, I'll be on the Zoom call on Wednesday. Just be there hanging out. If you need to ask a question, you can hop in. So I hope this helped. Hope you do well on the thing on Wednesday to kind of boost your score if you need it boosted. And then hopefully everybody has a good Thanksgiving. And I will talk to everyone later.